the no authentication, we have a lot of this infrastructure already baked into Visual Studio. So I'm just going to close up most of my files here. I'll just maybe close them all for now. I'll start my server without the debugger just to get it running. And then we'll just do a little quick tour of what kinds of files we have already here for security. So our app's running. So we have a number of things here. We have references to a whole bunch of NuGet packages that are involved in security. Actually, maybe we'll kind of see what. So here's what the architecture sort of looks like. So this whole infrastructure, there's been several iterations of this. And right now, we're using kind of a framework called ASP.NET Identity. So we've got an application here, or we've got a web application talking to our IIS server. And then we've also got some kind of list of users in our database. Now, we don't have this right now. There is no user store. We only have things like orders, albums. So we're going to need some kind of user store. ASP.NET Identity will actually take care of the user store for us. We don't have to build anything in our database. The library is going to do this for us. Then there's a couple of kind of tools that sit in between. We're going to have this middleware, which is already installed for us, called OWIN. And then it works with our entity framework library and ASP.NET Identity. It includes all of these things. So it's got libraries for managing users, for handling different roles and permissions, for sending emails, as well as enabling two-factor authentication should we choose that extra level of security. It also has a whole bunch of OAuth libraries for allowing third-party sign-ins for things like Google, Facebook, Twitter. So for us to plug into these is really easy. We have to write almost no code. Much of the code is already written for us.
Can you override this?
Yeah, and we'll look at how and why we do want to override it sometimes. We'll look at an example in a bit. So you can see when we create our project, you can see all these references here. So there's several that start with, so we've got the core library, the OWIN middleware, as well as the identity entity framework library. So these packages get added. And then down below, we have all of these OWIN libraries for doing third-party authentication. So it already automatically plugs in Google, Microsoft, Facebook, and Twitter. And there are other ones, if let's say we want to do something like LinkedIn, well, we just add the package and away we go. So we get those references, which we are going to need. We get an account controller. And the account controller has all the kinds of methods we would expect to have. Things for confirming a user's email, letting them log in through an external service, resetting a password, log in, and register. So it has all of these methods already built. So can we override them? Sure. And I'll show you, we'll look in a minute as to how and why we might want to do that. We get an account view model. So this is the view model that populates many of the views that the identity package builds. And then inside of views, we have an account subfolder with all of these views for things like register, login, forget password. So we don't have to build this stuff. We've already got it. Now for our music store, we're not going to need to override it. So I can just click on my register link and we actually get a form. I'll register in a bit, but not quite yet. So let's say we say, well, this registration form is good, but we need extra information from our users, right? So what's here isn't enough. Can we do it? Can we customize it? The answer is yes. So for example, this app got built last semester by a co-op student. We're using .NET MVC. We're using the ASP.NET Identity package, but the registration form here looks like this. Not just an email and password. We have user types and we had some other custom fields. So we had to add those custom fields to our database. I can actually show you the controller. Obviously, he customized the views with additional fields. And then in the controller, so in our register method, see our HTTP post. So here's our HTTP post for register. So we've added custom logic here. Okay, what type of user is it? If it's this type of user, we need to validate these fields. Otherwise, we need to validate those fields. And then we had to pass in, when we're creating the user, we had to pass in all of our custom fields. So it's just a starting point. It doesn't mean we're never going to change it. We have the ability to make any changes we need to here, right? Generate a confirmation email, etc. But it's a great place to start. We don't have to start from scratch. We can start with what the package gives us. So we've got a working register and login. Now, there's one really important point. I probably can't say this enough times. This package all works like magic, and one of the magical things it will actually do is it will build these tables in our database for us with these relationships. So it'll build a table to hold our users, a place for us to create different roles, and then a place for us, tables for us to set which user is in which kind of role for doing authorization. There's one key to making this work automatically. Here's the key to it. I'll probably repeat this several times in the lesson. This is the keyword. The ASP.NET Identity package looks for a connection string called default connection. That's why we've used this name. If we can name our database connection something else, but if we name it something else, the package will not auto-generate anything for us. So it's much easier to just use that name and let the automatic stuff work. So I'm just I would recommend, we need to connect to our database for a minute. We should look at what's in here. And then we'll see what happens when we invoke ASP.NET Identity. So I'm just going to connect to my database. Now you can connect here through your Server Explorer if you like. It's very slow. Your Management Studio connection is generally going to be much faster. So I would recommend using Management Studio. So I've connected, and I'll just expand my database. Now I already have tables in mind. I'm not sure why. Let's see what's in here. So in yours, you probably just have your 6 original tables. I'm curious what's actually in here. Because RP2 is not here. He's using my database. So here's what I want you to do. Click on your register link. Now it enforces strong passwords by default. So the password rules are minimum of 8 characters with at least 1 capital, at least 1 lowercase, and at least 1 number and 1 special character. So create an admin account for yourself. We're going to create 2 accounts. So I'll create admin@mail.com. And you may want to put this password in a file because we're going to need it each week. I'm going to register. Once I register, notice my register and login links are gone, and my header says, hello, it's got my username, and it says log out. If I check my users table again, I now have 2 users here. And if you refresh your list of tables after signing up, you just click on tables and click this little refresh, you should get these 5 new tables added to your database. The identity package will do that so long as your connection is called default connection. Chastain, you're nodding. Did it work for you? So now we can try looks like we have an account. We can try logging back, logging out, logging back in. So I'll log off and notice my links change back to register and log in. And now I can try my login page. I can log back in and log out with this account. Now we have a user account. We haven't created any kind of roles or permissions right now. So our first step is just authentication, identifying users by making them sign in. That's kind of step one. So our next objective is to make our store manager private. So if a user's not logged in, we don't want them to see the store manager link, and we don't want them to access any of the views that are here. So first, let's hide the link. Shouldn't be very difficult. We can just go to our nav bar, and we can write a little if statement that will determine whether or not to show this. In fact, it's similar. We can actually kind of steal the logic from this section here, right? Because there's already an if statement that determines what to show in the right side, whether to show register and log in, or whether to show hi and log off. So if I open up our layout template, you'll notice here, it's got this over on the right. It's an HTML partial called login partial. So that's this next view. It's not a complete view. It's a little component that sits at the top right of our nav bar. And there's some logic here that says, if the request.is authenticated. So this means if a user's logged in, we're going to show them the hello link that includes their username and the logout link. Otherwise, we're going to show them the register and login links. So we can use this same if statement around our store manager link, right? If request.is authenticated, then show the store manager link. We don't even need an else. Otherwise, that link just doesn't get displayed, right? So this link on line 26, I'll just move this list item. So now, if I log out, my store manager link should disappear. If I log back in, it should come back once I've logged in. Give that a try. So I log out, my store manager link is gone. Log back in.
Is there a way to actually set authentication on the page itself?
Yes, we need to do that next. You're one step ahead of me, Rick. We're going to get there in just a second. Because yeah, hiding the link that's the easy part of the job, right? Yeah. So when I log off, my link goes away, but I still haven't restricted any access. I'm not logged in, right? It doesn't show me any username here, but I can still get here. I can edit, I can delete. So just managing the navigation isn't nearly enough. We actually need to secure the store manager. What's awesome about ASP.NET Identity and the MVC model is we need one line of code to do this. So where do you suppose we would need to go to secure the entire store manager? You got it. So if we go to the store manager controller, right here on above line 13, so here's our controller class declaration. We just need to give it a little annotation as authorized. That's it. build. And now any of these methods in here will be inaccessible unless the user's logged in. So we've built. I'm just going to refresh. I'm not logged in, so I'm going to try and load any store manager page now. Now, this does a few things for us that are good. Takes us to the login page, which is good. Notice the URL though. What do you notice with the URL? We're not just at the login. Right. Now this is useful for a couple of reasons. Why do you suppose having that redirect parameter is useful? Right, so I was looking at album ID 365. So when I log in now, it takes me back to whatever page I tried to load, rather than me having to navigate. So that's useful. Can you think of any other reason that this is useful? It could, yep. One of the other things we might do, if we want to audit or log login failures, we can see where people were going and we could log those. One of the things I often do, we could put in a database, we could put in a text file, or we could email those to ourselves. And that's often what I would do, because every morning I would wake up with some of my clients and I would see things like this. I'd see stuff like that people were trying to log in and do things like inject SQL commands into the database. I would trap those errors and email those messages to myself. So most mornings I wake up and I see all kinds of hacking attempts in my applications because it puts that in the redirect URL. So now our store manager is completely locked. It can't go to any of the views in store manager with that one line. As soon as I guess I'm logged in. As soon as I log in. So we've locked this control, we've locked this at the controller level. None of these pages are accessible. Now we don't always want to do this. Maybe we want most of the pages to be secure, but maybe we have one or two that can be public. So in that case, let's say for a moment, maybe we want our index view to be public, but none of the other views public. All we would do here is we'd add in override authorization. So even though at the class level, the class requires authorization, this individual method does not require it. So index will now be public. All the other methods still require users to log in. I'll take this out, but I just want to show you how it works. So we have a very finely grained control. You can decide to make individual methods require authentication or a controller as a whole. Either way, the choice is up to you. So now I should be able to go to Store Manager, even as an anonymous user, but none of the links should let me in to change anything. So I'm not logged in. I can load the Store Manager, But as soon as I try and create a new album, well, the rest of that authorization applies. So this is really easy to implement and manage. The other thing we might want to do, if we wanted this page to be public, the other thing we could do is in our view, we could add some if statements around these links. We could say if the user request is authenticated, if the request is authenticated, show this link and show these links, much like we've done with the header. So when someone's logged in, they'd get a version of the page with all the links. When they're anonymous, they could see the data, but they have no links to change anything. So that's another way we could do this. I'm going to take that back. You know what? Actually, let's do that. No, it doesn't make sense to give them the store manager. Sorry, I'll take that back out for now. But that's how you would override it for a particular method. If that method has different rules, you can override.
There are only few methods which we want to authorize, and we don't want to authorize anything else in the controller. We just put authorize about that method. Right.
So if we have 20 methods and 19 of them are public and one of them requires authentication, you would just put authorize rather than here, you put it above the individual method. That makes that method require authentication, nothing else. So basically those are all you need, are authorize and override authorization, and you put them as you see fit. Now, so this is working pretty well so far, which is good. However, right now it means anybody can sign up, and as long as they sign up, they get access to the store manager. So I can log in here. So I'm going to create another account. Actually, wait, sorry. I'll hold off on that for a minute. So there's sort of two levels to security. So the first one is authentication, identifying who our user is. Do we know who they are, yes or no? So we've kind of handled that where we basically have two scenarios in our music store. We have authenticated users that can access the store manager. We have anonymous users that can't. However, most applications have a greater level of security, and the level beyond that has to do with authorization. Once we know who you are, what is it you're allowed to do? So if you're in lesson 6, if you click in here on Blackboard, notice you see different things than I see. It's the same page. There's not a student page and an instructor page. It's the same actual file, but things that are presented are different. What things are different? What are some things that are different between what you see here and what I see here? Right, so I have this section.
You also have these sections that you haven't enabled to force.
That's right, so I've got, yeah, I see this, you don't see that. What else is visible here for me and not on your version?
Creator package, thereof, you can create and add assignments.
Yep. So right here, this little nav bar, you don't see this. Right? These things are here. They're in the view code on your page, but there's logic determining whether you can see them or not. Right? They even give me the ability to see it as you see it. Gives me this yellow bar. So now I see, for some reason, it takes me back to the home page. They haven't fixed this yet. But I now see what you see. Right? So this is around authorization. We're looking at the same thing. We both have access to it, but I have additional things being displayed in mine that you don't get based on our roles. So what we want to do is we want access to the store manager. That's for administrators only. So what we need to do is kind of delve into our database, into these roles and user role tables. We need to create a couple of roles. We're going to have to do this directly in the database. And then we want to take that admin account we've created and give that user administrator permissions. Then we'll create a second account as a customer. And our customers don't get access to the store manager. So we're going to have to change the logic in both our nav link as well as our controller, that it's not just any authenticated user. It's only somebody who's an authenticated user and they're in the administrator role that accesses the store manager. So I have these tables here. If I look at my user roles table, sorry, my ASP.NET roles, I have nothing here. So this table, there's two columns. There's an ID and a name. They're both strings. The IDs are not auto-generated. We actually supply the role IDs. So what I'm going to do is insert two roles in here. So I want you to do this with me. So I'm going to insert into ASP.NET roles. Role 1, which will be administrator. And role 2, which will be customer. Make sure here this does not say master. Several students got errors today because they had their master database selected. You need to actually pick your music store database from this little drop down here. And then I'll just run a select query after to make sure these got inserted correctly. This is not case sensitive. Use any combination of upper and lowercase. So I'm just going to execute this. So now I have two roles in the database. We're doing this directly in the database because we have no web pages to manage the roles. ASP.NET Identity gives us a lot, but it doesn't give us those. So now I've got an admin user in the users table. We have a couple of roles in the roles table. We then want to insert that user into this table, which is ASP.NET user roles. So it's a user ID and a role ID. And one user can be in multiple roles. That happens sometimes. For example, just to give you an example here at Georgian, right? We've basically got three roles in Blackboard. We have students, we have faculty, we have administrators. So administrators can do things like set up new courses in Blackboard. I can't do that as faculty. I need an administrator to do it for me. But maybe an administrator might also teach a class. So they need to be in both the administrator role as well as the instructor role so that they can do both functions. So now I'm going to insert into ASP.NET user roles, user ID, role ID. I'm going to grab the user ID of my admin account, and I'm going to insert that person as an administrator. If I just run this query, I guess we never actually looked at the ASP.NET users table. I'll just execute this part first. So my ID, notice it's not numeric. Microsoft assigns a globally unique ID in the users table. It'll hash our passwords, generate a unique salt value, so those passwords are always going to be unique. So where I've highlighted in blue, use whatever email address you use to register your account. If you didn't use admin@mail.com, then use whatever you signed up as. So I'm just going to execute that command. So now it tells me that my new user ID is an administrator. It's in role ID 1. Here's the actual user table. So it has fields for a password hash and a security stamp. There's a salt value. It has a place for phone number if we want, whether the account is locked, and until when. So coming back to your question, we could customize that. If there's other things we want for our user, we can go ahead and add additional fields in this table. We're not limited to what's here. This is just kind of a starter place to start. So now I'm going to register a new account online, but this account will be a customer account, not an administrator. And then we're going to modify our code so that only the administrator account has access to the store manager, and the customer can log in, but they can't see the store manager. So I'm going to go back to my web app. I'm going to click on register. I'll create a customer account. I'm actually going to use the same password, but we can see how the hashing and salting means the password is not stored with the same value as my first user, even though I've entered the same password in my form. So I'll sign that user up. So now I've got, so if I look in my ASP.NET users, I actually typed the same password in, but because it uses this security stamp for salting, the algorithm generates a different value in the database. So even if we have 100 people create the same password, each one of them gets stored differently, which is more secure. It uses globally unique IDs that's just more secure, right? If they're trying to get at a user ID, it's easier to guess that there's a user ID 100 and then 101. This way it's just more secure. This way. So now I'm logged in as my customer. So right now I can go to the store manager, right? As soon as I log in with any valid credential, I can go to the store manager and I can add, edit, and delete data. So our logic here around the store manager, it's simply checking authentication. Is the user known or anonymous? We want to change this to be more like Blackboard's model. It's not enough to know who they are. We need to know if they actually have permission. So we have to change our logic here, and we have to change the logic in the controller a little bit. No big deal, really, really small fixes. So in our layout, instead of checking this condition, request is authenticated isn't going to do it for us anymore. Instead, we need to know if the user is in an administrator role. So we have a user object that comes with ASP.NET Identity. From this list, what do you think we're going to use? No. Yeah, we're going to use the isInRole method. If user.isInRole. Now we need to spell this correctly. This has to match exactly with the name in our ASP.NET roles table. If it doesn't match exactly, that'll return false. We can save that change. And now I'll try logging in first as an administrator, then as a customer. The administrator should see that link. The customer shouldn't see it. Here, so I'm logged in as a customer in Firefox. Notice my store manager link is hidden. I go over to Chrome, maybe I'll log in here with my administrator account. So as an administrator, I can see my store manager link. As a customer, I can't, because we're checking whether I'm in an administrator role. Now, we're not done yet, because Rick, this comes to your point about earlier, right? We haven't actually changed the permissions on the methods. We've just changed the permissions around the link. So as a customer, I can still go here. I don't see the link, but I'm not actually prevented from loading anything in Store Manager. I can still go here. I can still add, edit, and delete. So we're going to need to make a small change in the controller as well. It's not enough to just authorize. We have to authorize this controller for certain roles only. Easy to do. So in our authorize command here has some optional parameters. So if I open a bracket, we can specify a list of roles. So it could be multiple roles. We could also specify specific usernames if we wanted to. So in here, we just add roles equal administrator. That should do it. So a user must be in this role to access any of the methods in this controller.
You know, if this authentication goes faster if you use an int for a role rather than a particular string comparison?
I have not tried, so I don't know. I suspect if it does go faster, it would be pretty marginal. So now I'll try again. So I'll just log off in both places. I'll log off and then back on. So I'll log in Firefox as a customer. And now I'll try and go to my store manager. I'm still logged in, it just doesn't give me access to that page, which is okay. When I log in as an administrator, it checks my permission, it's checking whether I'm in the right role, and now all the store manager views are available. So this is pretty easy to manage. We just have to include individual user accounts when we set the site up. Make sure our connection string is called default connection. And then simply add any authorization code we want to whichever controllers, as well as any logic in our views that we need to show or hide things, make things visible, invisible to our users based on what they're allowed to do.
It takes us to the login page if customer is not authorized.
Right. Because it's asking to provide a login that has the proper permission, in effect, is what it's asking. So they are still logged in, but they can't get to that particular call that method in that controller without proper permission. So Microsoft, I think, has made this pretty easy for us. It's easy for us to customize, but it takes a lot of work away from us. They keep those packages up to date. So if there's an update, we can just update the packages and we get newer versions of things. So there was our local login. We're going to want to do some third-party login as well, but there's one other kind of important security consideration we need to look at before we do. Just a couple of other things I'll point out on Blackboard. There is I put a link here. This is a video tutorial from Microsoft. It's pretty similar to what we're doing in class, but if you want to learn more or see an alternate explanation, there's a 50-minute video kind of walkthrough where they do something very similar to what we've done. And you can see why in your assignment, even though you didn't have to do any security for part 1, I said I'm going to allow you to use the same project for assignment 2. It's much easier to not, if we didn't have authentication, it's hard to add once the project's set up. I think, Rick, we may have had a conversation about that. So there's a lot of files and references to add, so we're better off adding it in from the beginning. So a big part of assignment 2 is actually doing what we've just done here. It's making it so that the controllers and views you created for assignment 1 are now private. So in order to create, edit, read, maybe not read, but to create, edit, and delete data, user has to register and log in. And you'll just secure those parts of your application. That's part of what you have to do for assignment 2. One of the other things we should always be doing when we're building web applications is implement SSL. So we should spend a couple minutes talking about what this is. And then we're going to implement SSL in our application. Does anybody work with SSL before? Yep, so it's a security certificate. Rick, can you explain a bit more what it does?
It's cross-site scripting as well as it verifies that it is a unique signature. Hosted usually by a third party, but you can write your own certificates. It's not as trusted.
Yeah, generally. So in all of our HTTP traffic, right, every web application, all this traffic that goes back and forth between the client, whether it's a desktop, a mobile device, doesn't matter, and a web server, by default, this is all unencrypted. So everything that gets sent is just plain text. You build a registration page, the username and password, when the user posts that form, it gets sent in plain text. They pull up their profile, maybe it's something like their bank account from a database server, and the web server sends it back. It sends back plain text, which means any hacker that interrupts this traffic, they can easily read what's in those requests because it's plain text. So what SSL does is it encrypts the communication between the client device and the server. And there's different levels of encryption. Okay. So we've always used SSL for years. Basically, any site you had to log into, anything that was somewhat sensitive, we've used SSL for years. But many sites, if they were mostly public, they didn't necessarily need SSL. That's changed. Now we can see this site's using SSL. How can you tell Blackboard uses SSL? Yeah, we see the little green lock. If we click it, so Rick mentioned a signing authority on the certificate, right? We can view information about the certificate. So it was verified by DigiCert. We can see when the certificate expires. We can see so you can see it's encrypted with SHA-256, all the traffic between my machine and Blackboard. We can actually view the certificate and see the fingerprint, where it was issued, et cetera, et cetera. So we see the lock. We also notice that it's got an S. So the S tells us that the site's using a valid SSL certificate and the traffic is encrypted. What will happen? What happens if I take the S out? What will happen when I hit enter and try and load this same page, but I've tried to go outside around the SSL certificate? What do you expect will happen?
I don't expect you to log in, so that it'll reinstate the SSL connection, or it will error out.
It will say as unsecured connection.
So anytime we're building a site and using SSL, we need to check. This doesn't happen manually. Now, of course, Visual Studio makes this easy. We can do this with one line of code for our entire site. It will check every HTTP request, and if that request, any request comes in that doesn't use SSL, we redirect to the same URL, but with the SSL version. So we'll always want to check that. So here's what this kind of, I think we've done it here. So yeah, on our, you're at site. So if I go back to the home page and take out the HTTPS, we just do a check and send it right back. So one line of code in one of the configuration files will ensure HTTPS is always running. Now, this has become more important than ever. I put a link up here. I'm not going to read this whole thing to you, but I want to point it out to you. Now, there's a few reasons why this is really important. One is, as of 2014, Google started factoring in SSL into search engine rankings. So if your site has any forms, asks users for any input, even if it's not really very sensitive information, if that site doesn't have an SSL certificate, Google will punish you in the rankings. The other thing that started last year is if you have any login pages and those pages don't have SSL, it says not secure beside them. In fact, if I load our existing Azure site, I'll show you this. So my music store, which is on Azure right now, you don't see it on localhost, but if I grab the URL here and open this up in Chrome. Now, we don't need an SSL certificate on Azure because Azure already has one. It actually gives us the SSL, but right now it's not forced. You'll see once we load it. Hoping it will load. So we actually have an SSL, but we can go around it. So this is fine, it still works, but it's not secure. And when I go to the register or login pages, oh, it's super slow. We should see something like this in a minute. Wow. So notice it says not secure. So that's going to scare users away, as it probably should. So this is what it looks like right now. Eventually, and I've seen sites, eventually it's going to look like this. They're going to make it more noticeable. Now, realistically, there's almost no websites where it's just all static content anymore. Virtually every site we ever build has forms, will have logins, private areas. So we pretty much, I can't remember the last time I built a web application where I didn't need SSL. Okay, so you need them. So we need to set it up in Visual Studio, and we need to force our application, even when it runs locally, we need to force it to use SSL. So when we deploy it online, that SSL is being forced and users can't get around. Probably same here. If I try and go around, yep, just redirects me back to the HTTPS version. Now there's two ways you can get an SSL certificate. Okay. Actually, I'll just show you. You actually get a free one with your GitHub for Education pack. So you've all signed up for this, you get free private GitHub repositories, but one of the other things you get from Namecheap is you get 1 year of a free SSL certificate, which you can use. There's two ways in general you can get them. Most hosting companies will sell them to you. That's the easy way. You have a website on a host, you can typically buy SSL certificates directly from the host. They charge you, they install them, and it's done. Okay, you can't install it yourself. The server administrator and the hosting company has to install it. Typically, most hosting companies will charge somewhere between $50 and $100 for a certificate. So for example, GoDaddy offers hosting. They offer their own SSL certificates. Let's see what it costs. GoDaddy's SSL prices have gone up. They used to be really cheap. They're not so cheap anymore. And there's different levels, right? So this is on sale right now. Their lowest one is on sale, $60. That's American. So that's about $80 Canadian a year. Now, typically, you're not going to pay, you have to pay this typically. You set it up for your client and then they pay you back for the certificate is usually how it works. Because they don't know how to set it up. This is our job. They don't know they need them and they don't know how to set them up and manage them. So this is part of our job as a web developer. So yes, it's easier to just have the host do it, but they typically charge this much or more. I like to use these guys because rather than ask my clients to pay $80, I typically ask them to pay. Yeah. Now there are different levels. So this is a single domain. You don't get wildcards. Like the reason our Azure sites all use the same one, because Microsoft has a wildcard. So it's anything.azurewebsites.net is covered by that one certificate. So those tend to be more expensive. So there's different warranty levels. So Namecheap's prices range. Now the prices of these have come down a lot. When I first SSL certificate I ever bought, which is like 15 years ago, the cheapest I could find was $300 for the year. So they are much cheaper now. So it's cheaper to buy them here, but there is a bit of a process because there's some back and forth between the certificate issuer and the hosting company. And you get to be the messenger that goes back and forth. So I'll kind of show you what this process actually looks like. So the first thing you have to do is go to your hosting company. You have to get a certificate request for that domain from them. So it looks something like this. So you have to provide information about the domain, who the client is, their contact info. They're the ones who own the site. It's not you. And they will generate what's called a CSR or a certificate request. So it looks kind of like this. So then you go somewhere like Namecheap, you buy the SSL, you pay your $11, put in your credit card, and then you have to go and manage the certificate. So here is my certificate. So I have to take this code generated on the web server and I had to paste it in here because they need that code in order to create a unique certificate for this domain on this server. It also means that your certificates aren't transferable. If I move to another host, I have to get a new certificate reissued. So I put in that code. I asked them to issue me a certificate, and then it takes maybe 5-10 minutes, and then they emailed me a link saying, okay, your link to download the certificate is ready. Click here, and I had to download 4 separate files. So now I have the certificate. I have to put them up on the web server. So I downloaded those files to my computer. I connect to my web server by FTP, and I had to upload these 4 files to the web server. Now the certificate's not installed yet. It's just sitting on the server. It's a server administrator who has to take those files and actually install them. So once I uploaded them, I had to go back to my hosting company and say, okay, I've uploaded everything. Can you guys please install the certificate now? And then they responded a little while later. So this whole process, it took about 3 hours from the time I initiated it until the time they said, okay, yeah, you're good. Your SSL is installed and running. So you don't want to leave this till like the last day. So the expiry notices, you need to pay attention to them, because if you're forcing your site to use SSL and the certificate doesn't work, the site pages won't load, and then your client will freak out and call you. And it was all working fine. And the hosting company had a problem. Their server went down. They were attacked. They brought their server back online, except the SSL certificate didn't get restored. And all of my code was forcing every request to use HTTPS. So the site was offline. So my customer called me at the end of my morning class last Friday. I spent the whole lunch hour trying to sort it out, saying, what do we do? Because I knew I couldn't get the certificate back online right away. Now, fortunately, they didn't have any payment on the site. It was just a registration form. So I said to them, why don't we take off the SSL just for now while I get the certificate set back up? So the site ran without SSL for a few hours. I immediately had to call, get a new certificate issued. And rather than send a ticket, I called the hosting company and said, I need you to install the certificate right now because my client site, they've paid for an SSL, you guys broke it, you never fixed it. So I need you to get this one installed right away. And they were really good, and they did. By the time I was back in class last Friday afternoon for our class, the SSL was working. So that's kind of our responsibility to manage. So it is easier. You don't have to go back and forth. I could just bought the certificate here, but these guys would have charged me $75 US, which would have been a lot more expensive for my client. I just charged them the $11 Canadian I paid. So that's kind of the process of all of that. So we have an ability right now, our project locally is running without SSL. And as you can see, on Azure, there is the HTTPS, but we can just take out the S, and now the user is loading the plain text unencrypted version, which we really don't want. So what we want to do, will just take us a few minutes and then we'll take a break. We want to set up enable SSL on our project. So I'm going to click on my project, and I've got this little properties window here. If you don't see this window, you may have closed it. We want to turn it on. So we do that by clicking View and Properties window, third item from the bottom. If you click that, you'll get this window popping up. So there's a property down here. You can probably figure out what property we're going to modify, which property are we going to change. Yeah, SSL enabled defaults to false. Just double click, it changes to true. So now we have two URLs. We have a unencrypted and an encrypted version. So if I do that, now I don't know if I can go there right away. We'll try it. I'm going to copy that URL, the HTTPS version. We'll see if we can load it. We may have to build or restart the server. Okay, it actually tries to load. Now this comes to Rick's point. This looks like an error. It's not really an error. It's trying to load an HTTPS version, but it's saying, yeah, there's a problem here. So I'm going to click on Advanced. So here's the issue. It says your SSL is invalid because it's self-signed. We didn't buy it from a recognized certificate authority or issuer. Blackboard's was created by DigiSign. This one was created, I think we got this one from, let's see, from Komodo, so through Namecheap. So we haven't bought a certificate, so the browsers don't like this. Now we're just working locally, so I'm okay with this. We wouldn't put this online, so I'm just going to add an exception saying on my local domain, allow SSL to run. It's okay that our certificate is not issued by a third party. So I'll just add the exception, store it permanently, and say confirm. If you're in Chrome or Internet Explorer, you probably have a similar kind of warning. The screen may look a little different, but it will be similar. So I'll say confirm, and now it's going to load the HTTPS version. Still has a little yellow warning because our certificate is self-signed, but it does work. Yeah. It's because it's self-signed, but it does work and run under HTTPS.
So how this SSL certificate is created by the ASP?
It's on the web server, on the IIS Express, because the certificate gets generated on the server. So we can browse around now. Now this doesn't force HTTPS. This has enabled it, but it's not forced. So we could take the S out of the URL and try to go around it. So we're going to do two things so that our application always runs with HTTPS. We have to change one setting, write one line of code, and then we'll take a break. So what I want to do, every time we start our server, it automatically starts the HTTP URL. We want to change this, so every time we open this project and launch the server, we want it to run this to be the default instead. So just copy your SSL URL, just highlight it and copy it. And we're going to go into the project setup settings. So I'm going to right-click my project and choose properties, the very last item in this little pop-up menu. Not the solution, but the web project. So choose properties. And the third link on the left says web. And here's the project URL. So every time we start debugging or start without debugging, it loads the HTTP version. So I'm going to take that out and paste in the HTTPS version. So now each week when we open up our project and start it running, it will run the HTTPS version instead of the HTTP version. So that's one thing I'm going to change. So we've set our default to use HTTPS, but we still aren't forcing all requests. We've seen the way Blackboard or several of the sites, every time I take out the S, it redirects and puts it back in. So we need one line of C# code to force this. That's actually going to be inside of our app start folder. We have a file called filter config, this file right here. So these are any kind of global filtering. So for example, here's a global error handler. It adds error handling. So we're going to force all HTTP requests to use SSL. We're going to add a new filter. And what we want is this method, which is called require HTTPS. So we're setting all HTTP requests to require the SSL certificate. So once I put this up on Azure, my ability to do this, go here unsecured, that won't work anymore. It will automatically redirect me to the HTTPS version of the same page. So that's all the code we need to force SSL globally in the application. There are now no pages that can be loaded without HTTPS. If I try and load one, it'll just hang. On the server, it'll redirect. Locally, it won't, because our unencrypted version's running on a different port. So we should always be doing this. Forcing SSL, setting up our local project to run with HTTPS, and then buying and setting up a certificate on our domain. Now I'll just show you if I close, just going to close my project. You don't have to close yours. Just going to close mine and reopen it. So notice my server will be offline now. Right, I've taken my server offline. But once I reopen my project and start without debugging, rather than loading the HTTP version, it now loads the HTTPS, the startup version. It will always use SSL. So we're not running the HTTP version, we're running the HTTPS version. So yes, say you want to trust that certificate.
Then you get unable to launch the IIS Express web server. You'll put from IIS Express, failed to register URL blank for site, whatever application / error description. Now create a file, and that file already exists.
Let's think about that one. I haven't seen that before. Okay. It's 1:15, so we've been going for a while. Let's take a 20-minute break here. We'll come back at 1:35, and then we will try to enable maybe Google and Microsoft login as well. So rather than just signing in with a local account, we could sign in with a social account. We'll take a break here.